So today we're talking about the moon. Hopefully you were here in class and got to watch the preview of Apollo 13. Kind of get a feeling for why are we looking at the moon? What types of things are we looking at in space? Maybe in the discussion we had, why do we look in space at things? So note guide, hopefully you have the paper copy in front of you. If not, go make the e-copy so you can be taking notes as you're going through this. What is the moon? It is a natural satellite. A satellite is any object that orbits another object. It is one of the over 200 confirmed moons of our solar system. And of course, it is the only satellite of planet Earth. Natural satellite. It is about a quarter of a million miles away from planet Earth. Its diameter is about a quarter of the size of Earth. If you want to know the exact amount, it's 2,155 miles in diameter, and it's about 1/6 of Earth's gravity, which means one big step here is a gigantic leap on the planet, on the moon's surface. The birth of the moon, the giant impact theory. We may have seen a glimpse of this in a video, but we have changed our videos this year, so maybe not. So let's watch this, and we're going to watch this on YouTube. So we're going to.
For centuries, mankind has peered into the heavens at our moon and wondered where it came from, how it came to orbit around the Earth, what it is made of, and why there are so many similarities and differences in the Earth's and the moon's composition. The Earth's moon is unusually close to the Earth and is a key to life on our planet. It governs the ocean's tide cycles, which may have been necessary to prepare for the first stages of life in our oceans. But its origin has been the subject of a number of different theories. The current leading theory is that a planetoid about the size of Mars smashed into the Earth some 4.5 billion years ago, blasting off a chunk of the early, still developing Earth, and the remains of both planets came together to form the moon. This has become known as the giant impact theory. Astrogeologists have recently come closer to proving the theory by scientific examination of Earth and lunar rocks brought back by the Apollo missions. Evidence is suggesting that even life on Earth may not have been possible without a cataclysmic event early in the Earth's history. Giant cataclysmic impacts are not new to our solar system. It is generally thought that the planet Uranus, which is tilted on its side, got that way as a result of at least one impact, maybe two, by a planet-sized object in its history. Other planets in our solar system have also shown signs of gigantic impacts. The planet Venus has been the subject of such collisions. Venus, however, doesn't have a moon like ours, so the question arises, why not? If Venus suffered such a similar impact as Earth, why doesn't it have a moon too? There are several scientific explanations for this, which include experiments on how large the rogue planet would have to have been, at what speed it was traveling when it impacted, at what angle did it impact, what effects did gravity have on the remnants of the impact. Perhaps there was a second impact, or maybe a newly forming moon simply spiraled back into the planet. Such occurrences were common during the early formation of our solar system. These questions apply to the Earth too, when trying to determine what kind of impact would have been large enough to produce enough debris to form the moon without destroying the Earth completely, and also destroying the rogue planet Theia at the same time. The Earth was subjected to dozens of such collisions during its formation. The planets in our solar system were created by collisions between small dwarf planets orbiting the newborn sun. These collisions cause smaller planets to melt together and form larger and larger planets. One theory is that the Earth and the Moon were created at the same time as a result of a collision between two of the larger formed planets. The rogue planet, which is thought to have impacted with the Earth, was named Theia, after the mythical Greek titan Theia, who gave birth to the moon goddess Selene. According to the giant impact theory, there were many more planetoids other than Earth orbiting around our Sun during the solar system's development. Theia, which is believed to have been the size of Mars, is thought to have formed at the same time as the Earth and orbited our Sun too. Theia grew larger, however, making its orbit unstable, and eventually it collided with the Earth. In the last days of planet formation, a body as big as Pluto probably also smashed into Earth after the planet had been clobbered by Theia. Some theorists suggest that this is what could have knocked the Earth off its axis by 10 degrees, where it is today. Theia is thought to have struck the Earth at an oblique angle of about 45 degrees, when the Earth was nearly fully formed. A significant amount of mantle material from both planets would have been ejected into orbit around the Earth. It is estimated that about 20% of Theia's mass would have ended up as debris orbiting the Earth, and about half of this would have coalesced into the Moon. Scientists are trying to determine if this collision was a big splat, where the rogue planet simply merged with the Earth on impact, ejecting enough debris to form the Moon, or whether it was a hit and run, where a sizable chunk of the Earth and part of the rogue planet formed the Moon, and the rogue planet continued on its way, still out there somewhere. The Moon at that time was thought to have been very close to the Earth. It would have appeared 15 times as large as it does today, and would have had 4,000 times the pull on the Earth than it does now. It began moving away from the Earth and continues to do so today. Launched in 2008, NASA's Stereo Solar Observatory probes flank the Sun on opposite sides. They are entering an area where they will be able to search for any remnants of Theia which may still be orbiting inside our solar system. Did Theia survive its impact with Earth? If Theia collided directly with Earth instead of barely swiping it, and the collision speed was higher than originally assumed, Theia may have been totally destroyed. If, however, Theia was larger than Mars, hit the Earth with a glancing, slower motion blow, and simply tore off material that formed the Moon, it would have survived this hit and run and went on its way. Is Theia then on its way to interstellar space, never to return? Or was Theia sent into a trajectory that would eventually bring it back into our solar system for another encounter with the Earth?
Okay, so from the video, you should have got that the giant impact theory is what we call how the moon was formed. It was about 4.5 billion years ago. So the planet, our planet, was just barely on its way to being formed. We use the term planetesimal. I know she changed the term she used multiple times during that video. The name of that planetesimal was Theia, which they did fix in the closed captioning. I noticed that was good, nice. What else? And the debris from both objects. So some of Theia ended up back on Earth. Some of what became the moon is both Theia and the Earth. And we know this because of the Apollo missions. So they brought back there's been, I think, 15 total Apollo missions, and they have brought back several tons of moon rocks, and we can compare them to our rocks, and they are the same types of rocks. So we know that we shared this material because of this impact. So that's how we know this stuff. We're not just coming up with a story because it makes great uh, computer images, right? Okay. What does the moon look like if we cut it down? So, what is inside the moon? So, there's three major divisions. There's the crust, and we'll talk about the crust of planet Earth before too long here. There's the mantle, and the mantle on our planet is liquid. At one time, so was the moon's, but it is now solid because it is, again, much smaller than our planet. And the core. And just like with the sun, we've talked about the core of the sun. We'll talk about the core of our planet. Planets tend to have the more metallic centers if it's a rocky planet like ours. And just like our planet, the moon is rocky. So this one is also made of iron. So in some ways, the moon or any moon is going to be a lot like the rocky planets. What is the climate? Now, climate usually refers to atmosphere, so I'm using this word very loosely here. There is no atmosphere, so can't really have a climate. So there is nothing to breathe. There is no liquid water. The temperatures are very extreme. If you are on the daytime side, it is 130 degrees Celsius, which for those of us on in America, we're looking at 265 degrees Fahrenheit, a slow oven. And at nighttime, negative 190 degrees Celsius. That is below freezing by a lot. In Fahrenheit, that is a negative 310 degrees Fahrenheit. That is much colder than any place you can find on our planet. Is there ice on the moon? Yes. Yes, there is. How do we know this? We have two probes that we have landed on the moon that have definitively found ice. So we absolutely positively know that there is frozen water on the moon. What else about the moon? We have geographical features. That means what can I see as I'm traveling across the moon? So we have the craters. Almost all the craters are formed by meteor impacts. But then we have some that are formed by the volcanic actions. This is how we know that the mantle of the moon was at one time liquid. This one was formed by a volcano because here's the remnants of that volcano right there in the middle. The largest crater on the moon is over 1,500 miles. And in case you're wondering how big 1,500 miles is, if we were to go from Wheatfield, Indiana, we'd have to go all the way across to somewhere on the far side of Mexico City, roughly. Highlands and Mara. So they have mountains. Some of those mountains are very tall. They have rills, and you can see the rills right here. Are you looking right there? There are very tiny trench-like valleys. And then the word Mara, not Maria, Mara. Singular is the word mare. And these are dark, flat plains made by lava flows. So Mara, they were thought to be oceans or seas by the early astronomers. That's where the word comes from. They are the darkest parts of the lunar landscape. They're actually the basalt lava. So that's why they're so dark. They're black lava. Solidified, obviously. Filled with lava, so when the meteorites crash, it actually caused the lava to come up and solidify, or of course, in the case of the volcano areas. So we're talking about a lava that's 3 to 4 billion years ago. And as I said, basalt rock is what the mare made of. So here We have the craters. We can see them. They're roundish in shape. And you can see the indentation. And here is a mare. And over here is a different one. So some of the mera kind of run together. So, history of the United States exploring the moon. Through the 50s and 60s, we were using probes. Neil Armstrong was the first man on the moon, July 20th, 1969. Your your grandparents probably remember this because that's where my kids' grandparents can remember this. There are only 6 Apollo missions that landed on the moon from 69 through 72. It's only the course of 3 years. They brought back 842 pounds of rocks. What did I say earlier? I don't remember. You'll have to go back and listen again. How many people have walked on the moon? What do you think? Only 12 U.S. citizens total. And the last one was in 1972. No other countries have done so yet, as of the time of this video. That's the end of the video. Talk to you soon.